In stats, we began our final handout. Kind of exciting. We talked more about chi-squared testing, so the good news is you already probably know a lot of this. It's kind of like review. So while it is a formal handout, we already talked about it the rest of the week. So the chi-squared GOF test, it is a one variable test. That means we are comparing more than two categories, but there's only one characteristic of interest. Only if I took a subject, there's only one question I'm asking. All right. So if you're confused by that, look at page 2 here. This is one variable, birth month. And then here's a two variable. What type of cell phone, or phone I should say, and what their political party is. Two questions. This is another two-way. Anger, and this is, I think, a heart condition, heart disease. So two questions, that's a two-way. So GOF test, goodness of fit, is a one-way or a one-variable test. They could present, or they may ask you to present the null in three ways. So they may clearly say what they hypothesize the proportions are, and you just copy them. That's the best. They may say we suspect that they're all equal, so then you make them all equal. Or sometimes they make it into an algebraic equation, and in that case, you have to set it up equal to 1 and solve for x and calculate the proportions. That way really bothers me because that's just not very realistic. And then HA, we're going to test if at least one of them is different. So it's got to be random sample. Those expected values, you see the formula right here, have to be greater than 5. This is an exception here. This is a rare thing. I personally do not like it because I feel like it's kind of being lazy, but I don't know. If you did an expensive experiment and you ended up not having enough expected values, then I guess it's a way to still do stats, but I think it's kind of dumb. I skipped it. Degrees of freedom is number of categories minus 1. And the formula that's typed on your formula sheet, bottom of the page on page 1. Let's give it a try. Gladwell has this idea that, or I shouldn't even say it's idea, I think he's proven it, that many hockey players are born in the first quarter of the year. And that's so that they're bigger and stronger when they're younger. And they just get better playing time, get better hockey experience, I should say. So the big question is that the case? Are birthdays uniformly distributed throughout the year? So he breaks them into quarters, and we test it. So let's dive in. We are looking at proportions of NHL players born, whoops, I don't know where that came from, in a quarter of the year. So one thing I would do is I would note, I would note this is quarter 1, quarter 2, quarter 3, and quarter 4. So then in my hypothesis, I would just say we are going to assume that they're all equal. And by the way, this is all because of this word right here. We're going to test if they're not uniformly distributed. So we assume they're all equal. We assume that they are all 0.25. and we're going to test to see if at least one is different. Set your alpha. Move to the plan step. I scrolled just past it, but it did say random sample of 80. Something that I think is difficult with the GOF test is you have to calculate the expected values, and I don't know, you just have so much on your mind in the big test, it's hard to remember all these little things. So each expected is equal, because we're assuming equal, right? 80 times 0.25, so 20. All expected are greater than 5. All right? That's the condition for chi-squared. Expected values need to be greater than 5. So I move on to do the test. This is a chi-squared GOF test. I need to eventually write down what chi-squared is. I need to write what DF is and the p-value. So let's dive into the calculator and give it a shot. The next thing that people struggle with is, what do we do on the calculator? So I need to compare the observed values, these here, to expected. And the only way I can think to do that is with a spreadsheet. A matrix is for a two-way chi-squared, homogeneity or independence. But a GOF test, I don't want a matrix. I want to compare observed to expected. So you got to type them into a spreadsheet, make sure you name them, and run the test. And you pick GOF test. I named mine A and B. This is the other hard thing. You got to remember degrees of freedom. We had 4 categories, and it's 4 minus 1, so 3. And we got it. So 11.2 is the chi-squared test statistic, but this is the super important one. That's your p-value. This right here, the comp list, that's how much like deviation your observed counts had compared to the expected. It's not exactly like the difference. It's the chi-squared value. So it looks like quarter 1, January to March, contributed the most to a chi-squared value of 11.2, or we see that we reject, it contributed the most to rejecting. And then so did quarter 4. So let's wrap it up. We got 11.2, 3 degrees of freedom. The proportion of chi-squareds greater than 11.2 is 0.107, and that is smaller than alpha. So we reject HO. Evidence suggests at least 1/4 of the year for birth months for NHL players is not uniform, is not as stated, is not 0.25. You can say that a bunch of ways, but is not uniform. All right, I hope that made sense. See y'all later. Bye.